factor special products. So we're obviously still factoring, but these are special types, so they have basically like shortcut methods to factoring them. That you just have to be able to recognize the shortcut, and then makes it easy. So the first one, and my favorite one, is the difference of squares. And so this is if we have a squared minus b squared. So notice the difference in this is this just has two terms. Everything else we've been factoring has had three so far. And so this one only has two, the difference of squares. Okay, squared usually implies two, so hopefully that will help. Or like the difference of two squares. Anyways. So this is equal to a plus b times a minus b. So this always has to be here. The other key thing, other than that it has two pieces, is that it is a difference, meaning subtraction. So the only way this works is if there is something squared minus something else that's squared. And that can be variables, it can be numbers, it can be numbers and variables combined. We'll see all the different options for that one. The other one is a perfect square trinomial. And I don't do this all the time, but when you recognize, or on like a quiz or a test, if you recognize the special type, sometimes I'll give a bonus point if you write the correct name of the special type. So learning to recognize them and be able to write correctly which one it is can sometimes earn you some bonus points. Or I may say if you get all of them, you get 2 bonus points, or whatever. Anyways, but there's two options for this one. So it can be a squared plus 2ab plus b squared is equal to a plus b squared, or a squared minus 2ab plus b squared equals a minus b squared. So the thing here is it's whatever the first term is squared, the last term is squared, and then it's 2 times the first term times the last term is what the middle is. The sign of the middle always determines the sign out here. Okay. So an example of difference of squares, if I have 4y squared minus 64, what I would say to do as you're getting used to them is to write these things as the square of something until you're familiar with what you're looking for. So 4 is what squared? No, 4 is what squared? Like what squared equals 4? 2. So 2, we already see that y is squared, so 2y, all of that squared would be the same as 4y squared. Minus, what squared is 64?
8.
8, so this would be 8 squared. So now I do the first term, so this is difference of squares, so it's the first term plus the second term times the first term minus the second term. So this would be 2y plus 8 times 2y minus 8. And obviously working backwards works the same way. I think back while I was out, you used these maybe without realizing that's what you were doing. It was called the sum and difference pattern. But it's basically just difference of squares in the opposite direction. Anyways, but that would be the answer to that one. Obviously, we can still FOIL to check, but for the sake of time, I'm not going to FOIL them all. An example of a perfect square trinomial. h squared plus 4h plus 4. So obviously this problem in and of itself just kind of looks like the stuff that we've been factoring to this point, right? It looks like section 9.5, right, where we were just saying, okay, well, what are the two factors of 4 that add up to 4? And that would be what? 2 and 2. Okay, so we could do it the long way, and that's still absolutely fine if you don't understand the perfect square trinomial, but obviously the goal is that we learn the perfect square trinomial. So it's the first term squared. This is really what squared? 2 squared. So h squared and 2 squared. Then this middle term is 2 times the first term, which is h, times the last term, which is 2. And so that's what's telling me this is, in fact, a perfect square trinomial. Okay? So, again, you don't have to write it this way, but I just want us to see that that's why this is a perfect square trinomial. Just because the first thing and the last thing are something squared does not mean that it's a perfect square trinomial. That middle term has to be 2 times the first term times the last term in order for it to be. So, when this happens, this middle sign is positive, so that means that it's going to be the positive situation. So I do the first term, which is h, same sign, plus, and then the last term, what's being squared is 2, so h plus 2, and then that whole thing gets squared. Now, obviously with these, just like in all of our other factoring, we will get into factor and solve. Okay, so just how we factored, and then if it was set equal to 0, we would solve it on out. Same thing will happen with these as well. So you get lots of practice with factoring and solving in this chapter. All right, so the book is really nice, and they tell you under each section heading of homework, they tell you if it's a difference of squares or if it's a perfect square trinomial, and things like that. Obviously on the quiz and the test, I'm not going to tell you what it is. You're going to have to recognize what it is. Like I said, with the perfect square trinomial, it will still work the way that we've been factoring. If this just thoroughly confuses you, it still works the other way. This just makes it faster. But with the difference of squares, you have to know what that looks like. But it looks different than all the other ones, so hopefully that won't be too bad. One thing about this, to check this, we would have to write this as h plus 2 times h plus 2 to be able to check this. Okay, h plus 2 squared means that we have that written twice. So I'd have to write it twice to FOIL it to check it. Okay, and then we would just FOIL from here. I'm not going to do it again for the sake of time, but same rules apply. You should be checking these in the end to make sure that you've done them correctly. Okay, so jumping into the actual problems here, the first ones are difference of squares. And the book says the difference of 2 squares. I'm going to tell you, anytime you hear me say it, I'm going to say difference of squares because it's shorter and most books just say difference of squares. But anyways, so number 4. N squared minus 64. That's practically the problem we already had, but anyways. So 64 is what squared? 8. So I will think about this as 8 squared. So this is a difference of squares, so it's n plus 8 times n minus 8. To check it, I would just be FOILing. So what's happening here is we have n squared minus 8n plus 8n, so that right there tells you, okay, those things are canceling, and then 8 times negative 8 is negative 64, and so I just quickly checked that one. I'm just not writing it out. Let's see. 6. 49 minus 121 p squared. So this one's different because the variable is on the right hand side. I know normally we like to write our variable first, but I can't flip this, okay, because then it's not a difference of squares if I go and I move it around. So I just have to leave it as it is. So what squared is 49?
7.
So I want to think about that as 7 squared minus what squared is 121? 11. So this is really 11p all squared. Okay, that would give us 121p squared. So now my difference of squares would be 7 plus 11p and 7 minus 11p. Now, I basically will always do plus then minus. It's totally fine if you do 7 minus 11p times 7 plus 11p. They both are the same thing, right? Doesn't matter what order they're in, as long as they're both there. One's positive, one's negative, we're good. Let's see. 8. 225 x squared minus 144 y squared. Is there something that we can square that's equal to 225?
15.
I think so. My follow-up question would be, is there anything I can take out of this? I can't do 12 because 225 is not even, but three's a good start.
You do 9.
Okay, so if I do that, okay, if I did 3, let's just say I know that 144 is divisible by 3 because it's divisible by 12, right? 225 is divisible by 3, probably also by 9. Wrong color. So if I don't know, now I'm going to show you, we can do this 2 different ways. The book does it by factoring something out first, which is why I'm doing this. So if I take out a 9, that's 2, 18, 4, 5 is 45, and 0. So I can take a 9 out of this and I would be left with 25. If I take a 9 out of 144, 195, I get 16. So I can take a 9 out of all of this and it'll make it easier, okay, if you don't recognize that 225 is 15 squared. Then we can do it that way, obviously. So 9 times 25x squared minus 16y squared. And then we can do this as a difference of squares because these are things that we know and are easy to work with. And so this would be 9 times, now I'm dealing with what's actually in here. 25 is 5 squared, so this would be 5x would be the first term, plus 4 squared is 16, and then that's y, so 4y times 5x minus 4y. So this is how the book writes the answer. But I'm okay if we recognize that 225 is 15 squared by writing this as 15x plus 12y and 15x minus 12y. Either way is fine. They both will give the same thing if you FOIL them back. Just when you FOIL this one, you also have to multiply it by 9 to get back to that. Anyways, either of these would be fine. However you want to do it. Any questions on that? Okay. The next ones are perfect square trinomials. We'll kind of be back to those in a second, or to the difference of squares with some of the other problems, but perfect square trinomial. Y squared minus 10y plus 25. So obviously this first term is just y squared. Over here, 25 is what squared?
5 squared.
So that's 5 squared. And then in the middle here, it needs to be 2 times the first term times the last term. So that means 2 times y times 5, which is 10y. So that's good. This is 2 times 5 times y, which means that that's, in fact, a perfect square trinomial. Again, I'm not requiring that you write that part. I just want you to see that that's why this is. So now we do the first term, the sign of the middle, and then the last term, whatever's being squared. So in this case, it's 5. We put parentheses around it, and it's that whole thing squared. And again, if you were going to check this, you need to write this as y minus 5 times y minus 5, and then FOIL it so that you can do it. Uh, 12. 9t squared minus 12t plus 4. So this first term is 3t squared. The last term is 2 squared. So that means my middle term, if we keep the sign, should be 2 times the first term times the last term. So that means that this is 4 times 3 is 12, so I'm good there. This is, in fact, a perfect square trinomial. So then this would factor into first term 3t, sign of the middle, minus, last term is 2, and we square it. (14) 2x squared plus 12xy plus 18y squared. Is this a perfect square trinomial?
No.
Why?
There's no minus.
It doesn't have to be minus.
2x.
Doesn't matter.
It's because of the y and the x.
Is 2 a perfect square? What squared equals 2?
Oh, okay.
No, it's not.
So that's right. That's the problem right now. But they've told us in this section that this is a perfect square trinomial. Any ideas what I can do? What do all these numbers have in common?
Or you know,
They're even.
They're even, so what does that mean? I can automatically take out
2.
a 2. So I'm going to take out a 2. And then I'm left with x squared plus 6xy plus 9y squared. Now is this a perfect square trinomial?
Yes.
Yes, because this is x squared. This is 3y squared. So if you want to think about it, 3y squared like that. And then the middle term is 2 times the first term x times the last term 3y. Well, 2 times 3 is 6, and then I've got the x and the y there. So the variables, multiple variables, things like that don't matter. The fact that both things are being squared is what matters. So I've got x squared and I've got y squared. If this was just a y, I couldn't do this, okay? But because this is being squared, this is a perfect square trinomial. Don't forget the 2 that we factored out. It's got to go down with it. So this is going to be 2 times x, sign of the middle, plus 3y, and then all of that squared. I say all of that squared. The stuff in parentheses squared. So sometimes we have to factor something out first. Sometimes we can just go right away. And again, I knew that this was a perfect square trinomial. You could have still factored this without knowing that it was a perfect square trinomial using the methods from the previous sections. But because they've told me this is a perfect square trinomial, I can go about it that way. All right, the next ones just say to factor the polynomial. So these aren't going to tell us what they are, okay? So 16, 4f squared minus 36f plus 81. So what does this kind of look like it might be?
Perfect square.
Yep, it might be a perfect square trinomial. Obviously, we need to check and see. But I know that I've got 3 terms, so it can't be a difference of squares. So the first term would be 2f squared. What squared is 81?
9.
So 9 squared is here. Now I've got 2 times the first term, so that would give me 4f so far, times the last term. Well, 4 times 9 is 36. So I know that this is 2 times 2f times 9, which is 36f. So this is a perfect square trinomial. How would I write it?
Um, 2f minus 9 squared.
Yep, 2f minus 9 all squared. So it's first term, sign in the middle, and then last term. And again, you should be checking these as you go, so make sure that you're doing them right. But I have the answers in front of me, and I've been doing these long enough that I know if they're right or wrong. Okay, I don't normally do an odd one, but this one is a little odd, so I'm going to do it. Negative 9r squared plus 4s squared. What's different about this one?
Not a trinomial.
It's like a difference of squares, but there's a numbers. Different variables, yeah.
Yeah, so it is a difference of squares, but it doesn't look like all the other difference of squares that we had, right? All the other ones were a positive number, then a negative number. Positive, then negative. Positive, then negative. But this one is negative, then positive. Okay? So in order for us to write this as a difference of squares, I need to swap these 2 terms. Okay? So I'm going to write this as 4s squared minus 9r squared. Now, both numbers are perfect squares. If they weren't, I couldn't do it. Okay? But they are. So this is 2s plus 3r times 2s minus 3r. Okay, so it's whatever is being squared here plus whatever's being squared here times whatever's being squared here minus whatever's being squared over here. So that would be the answer to that one. I want you to do this one by yourself. 18 z squared plus 12z plus 36. So take a minute and try that one. Do you have an answer?
So z plus 6 squared or all
Do we agree?
Oh,
Good.
I did it.
I thought I was cooked. So did I.
Yeah.
So the last term is 6 squared. The middle term is 2 times that number, so 6 times the first term is z. I know I just said that out of order from what I normally say, but anyways. So that's z plus 6 squared. So that was a perfect square trinomial. One more I want you to do by yourself, and then I'll give you some problems to do. We're going to do the rest of this section tomorrow, but we're going to do the and solve part tomorrow, basically. All right, 23. Negative 45x squared plus 20y squared. So your hint is you may have to take something out first. Do we have an answer?
2y plus 3x and then 2y minus 3x.
Do you agree?
I'm not cooked. It's honestly a lot easier than I thought it would be.
Now, I'm going to tell you one thing about this problem, because if you go back and look in the book, you're going to be like, that's not the answer that's in the book. Now, I'm going to show you something. This problem was a multiple choice question, okay? And their answer was negative 5 times 3x plus 2y times 3x minus 2y. Can you tell what they did?
They didn't like move it to be like 20 y's in front.
What did they do instead?
They kept the negative 9 instead of moving.
Sort of. So what they did is, instead here, when I took out a 5, instead what they did is they took out a negative 5. And when they did that, that made this 9x squared minus 4y squared. Okay? And then they worked it down, and ultimately they would have gotten to this, what's written in red here. Okay? So, if you had done it that way, that also would have been fine. The main reason I'm telling you that is because that was a multiple choice question, okay? If you had gotten this, your answer would not have been there. Obviously, I'm not giving you multiple choice questions on a quiz or something like that, but I'm mainly telling you so that if you go back and look at problem 23 in the book and you're like, my answer's not there and she said this was right, then you'll know, okay? Yes.
So, like, is it fine that I switched, like, negative 45x squared
Yeah, I almost did it that way, and then I was like, well, since I just said something about taking out the 5, they're probably going to do that first. That's the only reason I did that. But yeah, I could have swapped it first, then taken it out. I get the same thing either way. So yeah, but if you take out the negative number, then you don't have to swap them, which that same thing would have happened if we had done that. I don't even know where that problem was now. What problem was that? I could have done that here. I could have taken out a negative and also have done it that way, but I think that that's more confusing than just swapping the numbers. I would do what I did in blue. I would not do what they did by taking out a negative, but you can obviously do it that way also. Did you have a question, Abby?
Yeah.
Okay. All right. Any questions on this stuff, or we feel okay about it for right now? Enough to try it? Okay. All right. A few problems then. 3 through 15 odd, and then also 19 because we already did 17. So tomorrow we'll finish up this section. You can I want you to work on the problems now. You've still got 15 minutes. I want you to do these, but just hold on to them when you're done. You're going to add the remainder of this section's work to it after we finish it tomorrow. Okay, so tomorrow's just the and solve part. Monday we're going to do 9.8. So we're going to quiz on Wednesday on 9.7 and 9.8. Test next Friday on the entire chapter 9. Okay.
What's it going to be again?
Wednesday.
Okay, man.